So today I'm going to build an evil possessed doll. I'm then going to prank my two kids with it. At the very end of today's video, I'm going to show you how you can make one at home yourself. I'd like to introduce you to Chubbs. I built this with a micro computer chip and some basic fundamentals of robotics. Now let's see if we can prank Maddie and Grayson.
Why are you doing it downstairs? Why are you spraying?
We're doing it up here too.
Why are you spraying?
Just watch TV.
Why are you spraying?
We'll be right back. Look at this.
Why are you spraying?
You've been tricked. Smile into the camera. You've just been pranked. How do they say it? You've walked the prank.
No. Please.
Okay, so if we had to give ourselves a grade, I'd give us a solid 7 for the prank rating. I think we did pretty good. So if you want to make one of these at home, we're going to give you a very quick crash course with this video. You can find all the information and details on our website. The link is in today's show notes. So everything starts with designing a circuit that controls everything. And to do that, we used an Arduino circuit computer board. Displaying on the screen here is an Arduino Uno. We actually used a Mega 2560, really the same thing, just a few differences with the technology capability. So with our servo, we're going to control the doll's head and make it move left to right. We have 3 different wires that are leading from the servo. One controls the input, and we're going to run that directly to digital input number 12 on our Arduino board. One controls power, and we're going to run the power wire directly to the 5-volt input on our Arduino. And then one is a ground wire, and we're going to run that to the negative row on our breadboard. Now, we got to connect the negative instance from our board to the negative row on our breadboard. So to do that, we're going to run a wire from the ground input on our Arduino to the negative row on our breadboard. Okay, so now it's time for us to wire up our 2 red LED lights. To do this, we're going to use 2 220 ohm resistors to lessen the voltage so we do not burn out the LED lights. So we're going to plug one end of the resistor into the negative row and the other directly across into the middle section of the breadboard. We're then going to plug the negative end of the LED light, just a little tip, that's a shorter end. And we're going to plug that in line with the resistor and the other directly across, as you see in this circuit diagram. Now we need to run 2 control wires from our Arduino board to the breadboard for the lights. This will basically control when they turn on and off. To do that, we are going to use digital input 11 and 10. We're going to run those directly over to the breadboard, as you see in the diagram. The last thing that we need to do is wire up our buzzer. To do that, we're going to take the positive end of the buzzer, little tip here, that's the long end, and we're going to plug that into the digital input number 8 on our Arduino board. We're then going to plug the negative end in and run that over to the ground terminal on our Arduino board. And that's it. Okay, everybody, now is when the fun really begins. It's time for us to write the code that will control the circuit we just built, therefore allowing us to control our evil possessed doll. Now, to do this, you can see I've opened the Arduino software, also known as the Arduino IDE, or Integrated Development Environment. This is basically a word processor for writing code. Now, the Arduino software is 100% free. You can download it on their website. So to get started, we need to define the library that we want to use. Arduino has several different libraries, and it essentially allows you to complete an executable, such as turning on an LED light. In our code, we are going to define the library with a hashtag include, and we're going to identify servo.h, and that is our library. So next, we're going to want to create a servo object to control the servo later on down in our code script. So to do that, we're going to identify the servo, and we are going to call it my servo. And I'm going to put some notes here next to this. Create a servo object to control our servo. Okay. Next, we need to identify the stored servo position where we want our servo or our doll's head to start at. To do that, we're going to use int POS equals, and in our case, we're going to set this to 170 degrees. And I'll make some notes. A variable to store the servo position. Okay, awesome. Next, we need to define our two LED lights that we plan to use and their relation to the digital input that will control them. So to do this, we are going to use int capital LED 1. That will, of course, be the first one. And we are going to use digital pin 10. We now need to identify the second LED. And for this one, we are going to use pin 11. Just like that. Okay, now what we need to do is identify or call out the Arduino setup function. And this is basically used to initialize variables, pin modes, and to start up specified libraries. This function will only run once after each power-up or reset of the Arduino. So to get started, we're going to use void setup. There we go. And there we go. So now we are ready to begin. And we are going to identify my servo dot attach, and there we go. And essentially what this would do is this attaches the servo on pin 12 to the servo object. So now what we are going to do is pin mode LED 1, right? And this is going to be output. Just like that. And back out. Here we go. And then mode LED 2 output see, we're going to 8. Right. Okay, I feel pretty good with that. So there we go. I've defined the void setup. We're now going to begin our loop that we want to run upon our Arduino board being powered on. So to begin this, we are going to identify the loop, just like I am here. Now we begin. So in our instance, I want to delay our Arduino and circuit from starting for at least, let me think, for at least probably 15 seconds. So I'm going to identify this. This is in milliseconds, by the way. Okay, so you can see delay 15,000 milliseconds or 15 seconds. And the reason why I am doing this in my case is this will give me enough time to power on the Arduino and allow for me to exit the room so that way Madison and Grayson do not expect anything and I can get the prank that I desire. Okay, so now what we're going to do is, again, in our case here, we are using a buzzer. So I'm going to set that buzzer instance right now. Actually define it just like this. Okay. And then we're going to have that delay for okay. Now we're going to have, now that we did that, we need to turn the buzzer off, right? So again, the reason why I've decided that I'm going to use a buzzer is because I want to get Madison and Grayson's attention. I feel like this is a really easy way to do that. Right, so then after the buzzer turns off, we're going to delay, and I'll just set this for 1000. You can play around with these numbers as you develop your code. Okay, so now the buzzer has turned off. The next process is that we want the 2 LED lights to turn on at the same exact time. To do this, we are going to utilize the digital write feature, okay, just like that. And we're going to first identify LED 1. We're going to use the high callout. And what this does is, with high, it turns on the LED light, okay? And I'm going to put some notes here. Turns on LED 1. I'm going to do the same exact thing with the second LED. So digital right. This time we're going to call out LED 2. We're going to set it to high because we want it to turn on. I just noticed the one up here. Okay, there we go. Make some notes here as well. Turns on LED 2. Go. Perfect. Okay. So now, basically where we're at in our loop is we've set a delay. After the delay, our buzzer turns on to get their attention. After the buzzer turns off, there's a very small delay. And then we have the 2 LED lights turn on. And what we want to do next is set a delay. After these turn on, we're going to set this, let's say, for, there we go, that's what I've decided upon. Okay, so now what we need to do is we now need our LED lights to turn off. So to do that, we're going to use the digital write again. We're going to identify LED 1. This time we're going to set the value to low, and this will turn off our LED. Right, so again, I'm going to turn off LED 1. Perfect. I'm going to do the same exact thing for the second LED. 2, low. Okay. Perfect. Now that we have that, again, we're going to just set a delay after this happens. Okay, perfect. So now that our two red LED lights, or the doll's eyes, have turned on and turned off, we now want to control our doll's head with the servo. So to do this, we are going to start with 4. We'll identify the position. We're going to set this to 155 degrees, right? And then we will use here to 180. Here we go. And then POS. Let's set this to 1. And here we go. And essentially what that 1 does is this actual line basically states that we're going to go from the starting degree to the secondary degree that we've identified in steps of 1 degree, right? So just like I have done above, we're going to identify that as goes from 155 degrees to 180 degrees. And we will say in steps of 1 degree. Here we go. So now, once that completes, we basically want to now identify, let me think how I want to write this. I'm going to actually tab in. I'm going to say my servos. I'm going to identify it again. I'm going to want to write position, right? And I'm going to say delay 15. And this basically identifies that we're going to wait 15 milliseconds for the servo to reach the position. So we're going to wait 15 milliseconds. Okay, feel like we're pretty good there. We can go ahead and end that there. So basically where we're at now, if you're following along without much confusion, I'm going to break this down here. So far in our loop, we've identified a delay of 15 seconds. We then, after that delay, have identified we want our buzzer to turn on, very short delay, and then turn off. After the buzzer turns off, we're going to turn on our 2 red LED lights. Those are identified here as LED 1 and LED 2. We then have a small delay and the LED lights turn off. We then have our servo motor, which basically controls the movement for our evil possessed doll's head. We've identified that we're going to have it go from a position of 155 degrees to a position of 180 degrees. And that step will be in 1 degree increments. We're then going to have a 15 millisecond delay for the server to reach the position. Okay, so that's where we are right now. Now basically what we want to do is we want to identify the servo movement to go back from 180 degrees to 155 degrees. So to do that, we're going to say for, going to identify position equals 180 degrees. Position again. This time we're going to write it like that, and we're going to go back to 155 degrees. And just like before, only this time. I'm going to use one again. Here we go. Okay, so again, we're going from 180 degrees to 155 degrees. So I'll just make a little comment here. As above, only this time we are going from 180 degrees to 155 degrees. Okay, here we go. So now once that completes, I basically want to identify again here. Just trying to think how I actually want to write this. And on this, just like I did above, my servo dot right, and like that. Now we want to put a delay here. Delay, just like I did above. Right. So again, just like above, this is going to wait 15 milliseconds for the servo to reach the position that we've identified. And I'll basically just take a second up position. Okay, perfect. All right, now what we're going to do is want to basically, okay, so now I'm in line with 4, and I want to close out there, and now we're going to close out completely. Okay, and now if we did everything right here, our code should work perfectly. So again, one more time, I'm going to explain this very quickly. So hopefully this will answer any questions or confusion you may have. So to start here, the include servo, we've basically identified the library that we want to use. This library ultimately will control the executables for our sketch or script. Here, we've identified servo, and in our particular code string, as you've seen, we're going to use my servo to create the servo object. We then identified the servo position that we want to store, which is 170 degrees. We've identified the 2 LED lights that will ultimately become our evil possessed doll's eyes. Those are LED 1 and LED 2, and they correspond to the digital input pins on our computer circuit of 10 and 11. We then identified the setup, and ultimately this attaches the servo on pin 12 to the servo object. Coming down here, the void loop officially begins the actual loop that will continuously repeat itself until powered off. So in our particular instance, we're going to start with a delay of 15 seconds, and you can change this, you can delete it. It really depends on what works best for you. The reason why I've set it like this is because that gives me enough time to power on the Arduino and then leave the room before our evil possessed doll comes to life to prank our kids. After that delay, we then have a buzzer, and this buzzer turns on. It then turns off. Right after that buzzer turns off, we have the 2 LED lights, the 2 red eyeballs turn on, and we've set a small delay. And then we identify that we want those 2 LED lights to turn off. Now, once the lights turn off, we then have identified here that we want our servo to rotate from 155 degrees to 180 degrees. And remember, on the servo is our doll's head. So this will actually make the doll's head slightly move from left to right. So after it moves over to position 180, we set a very short delay, and then it moves back from 180 degrees to 155 degrees. That then ends our code script, and the entire thing will repeat itself. So there you go. Very simple. Hopefully you followed along with that without much issue. All right, y'all, we made it to the final step. It's now time for us to put all of our circuit components inside of our baby doll. To do this, I'm not going to go into full detail. I am going to show you some behind the scenes content on how I did this. Again, just one more time, I used an old baby doll of my daughter's that's been laying around the house for a very long time now. I did make some modifications to it. Just a little tip that I'll give everyone: to extend any of your circuit devices, such as a servo or the LED lights, to get them inside of your doll, you can simply use your jumper wires. So I attached the jumper wires to the breadboard. I then attached the actual device that I want to control to those jumper wires. In many cases, I'm able to extend this 2 to 3 times the initial length. So again, get as creative as possible when you are creating your evil possessed doll. We really hope that you enjoyed this video. This was part of our DIY make your own Halloween props at home. We are going to have a few other videos become available hopefully before Halloween. So if you actually make a evil possessed doll of your own, share it with us. We would absolutely love to see. You can find our circuit schematic and Arduino code for this project on our website. The link is in today's show notes. And to everybody, all of our very loyal audience, we thank you for everything. Until next time, take care, everybody.